Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
This one question lost more marks than any other on last year's AQA higher paper, and it's actually easy if you know the trick. Students knew the rules, but under time pressure they picked the wrong theorem and lost 2 marks. Stay with me. If you listen to the next 2 minutes, you'll stop making that mistake.
Sound familiar? I remember staring at a circle diagram and just panicking. Any tip that saves 2 marks sounds like a lifesaver.
Good, that's exactly the point. Today we're narrowing to 3 exam-winning theorems: angle in the semicircle, angles in the same segment, and the tangent relationships. We'll keep it practical: how to spot each situation, why the theorem works in one short sentence, and the exact things the examiner wants to see. Ready? Let's work through this step by step.
First, angle in a semicircle. The setup: if you see a diameter, a straight line across the circle through the center, then any angle formed at the circumference using the endpoints of that diameter is 90 degrees. Why? Visualize the radius lines from the center to those 2 endpoints. They form an isosceles triangle with the center, and the angle at the circumference sits on a straight line, so it must be a right angle. In exam language, angle in a semicircle equals 90 degrees because the arc subtends a right angle at the circumference. Write that short reason, and you'll often pick up a method mark.
So if I spot a line through the center and points A and B on the circle, any angle with A and B at the ends is automatically 90 degrees, right?
Exactly. Second theorem, angles in the same segment. If 2 angles stand on the same arc, they are equal. Picture 2 different points on the circumference that both connect to the same chord. Those 2 angles have the same size. Why? Both angles subtend the same arc, so they intercept identical sets of points on the circle. Practically, if the question gives one angle in that segment, you can transfer it across. Big time saver when you need to find another angle quickly. Third, tangent relationships. There are 2 small rules that appear all the time. 1. A tangent to a circle is perpendicular to the radius at the point of contact, so that angle is 90 degrees. 2. The angle between a tangent and a chord through the point of contact equals the angle in the opposite arc. In plain English, the angle made with a tangent is the same as the angle standing on the opposite side of the circle. Why this holds comes from congruent alternate segments, but in exams, a clear written reason like tangent perpendicular to radius or angle between tangent and chord equals angle in opposite arc wins marks. That's the bit that confused me, that tangent to chord rule. So I should always check, is there a tangent line and is there a chord meeting it? If yes, I can equate those angles.
Yes, and that checking step is part of our quick checklist later. For now, let me give a simple verbal diagram that you can picture in the exam. Imagine circle center O, tangent at point T, chord TB to another point B. The angle between tangent and TB equals the angle subtended by TB at the opposite side of the circle. Write the short reason and quote the theorem. The examiner loves precise wording.
Before we move on, one small but critical note. Never just state a number without a reason. On higher papers, that difference between I know the rule and I can apply it under pressure is where method marks live. The examiner wants to see the link, so write it down, don't just think it.
Right, exam technique. Let's take a typical 4-mark circle question. You might be asked to find an angle, knowing a diameter and a tangent. How are the marks allocated? Usually, M1 for identifying the correct theorem or setup, M1 for establishing a relation or equation using that theorem, M1 for carrying out the correct angle arithmetic, and A1 for the final answer, with units if needed. So even if you can't finish the arithmetic, the examiner can still award the earlier method marks, which is why writing intermediate steps is vital.
Examiner phrases that pick up method marks. Angle in a semicircle equals 90 degrees. Angles in the same segment are equal.
tangent perpendicular radius at point of contact, or angle between tangent and chord equals angle in opposite arc. Use those exact short phrases in your working. They signal to the examiner that you know which theorem you're applying. Say the reason, show the step, do the arithmetic. So when I write my answer, I should do something like angle ABC equals 90 degrees, angle in a semicircle, therefore, and then continue. That will score M1 straight away. Exactly. Put the theorem first in one short line, then show how you apply it. Even better, box your final answer so the examiner can find it quickly. Now, the single common mistake. Students apply the wrong theorem because they only glance at the diagram. They call something a diameter when it isn't, or they assume a line is tangent without checking the perpendicular radius condition. Read the diagram carefully. That's where marks are lost.
Quick win time. One checklist you can use on every circle question. I want 3 quick checks you can do in 10 seconds before you start calculating. Say them out loud with me. 1. Spot the centre or diameter. Is there a straight line through the middle? 2. Look for equal arcs or repeated angles. Are 2 angles standing on the same arc? 3. Check for tangents. Does a line meet the circle at exactly 1 point? And is there an obvious radius you can draw? If you answer those 3 in order, you will almost always pick the right theorem.
I can remember that. Diameter, same segment, tangent. DST. That's easy to say under time pressure.
Perfect. DST. Add one tiny habit. After you get your angle, substitute it back into the diagram or a small equation to check consistency. Takes 10 seconds and catches 90% of sign or labeling errors. Don't skip the check. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam.
Now, a short new-style practice question. Read it, pause, and then I'll walk you through exactly what to write for method marks. Question. On circle O, AB is a diameter. Point C is on the circumference so that AC meets BC at C. A tangent at B is drawn, meeting the extended AC at D. Given angle ACB equals 35 degrees, find angle CBD. Take a moment to picture it.
Okay, diameter AB means angle ACB is 90 degrees if C were on the diameter, but here ACB is given as 35 degrees. I'm mixing it up. Don't worry, step through DST. Step 1, diameter. AB is a diameter, so any angle standing on AB is 90 degrees, but angle ACB does not stand on AB in the way you first thought. Step 2, same segment. Angle ACB subtends arc AB, so angle ACB and angle ADB, if D is on the opposite arc, would be equal. Step 3, tangent. At B we have a tangent, so angle between tangent BD and chord BC equals the angle in the opposite arc. That opposite arc angle is ACB, which is 35 degrees. So write this out, angle between tangent and chord equals angle in opposite arc. Therefore angle CBD equals 35 degrees. That's the key line to score M1 and M2. Your final answer is 35 degrees.
So the correct write-up would be something like angle between tangent BD and chord BC equals angle in opposite arc equals angle ACB equals 35 degrees, angles in alternate segments. Therefore, angle CBD equals 35 degrees. That gives the method and the answer.
Exactly. And the common mistake to avoid here is saying the tangent is perpendicular to the radius and trying to use 90 degrees where it's not relevant. Check whether you're supposed to use perpendicularity or the alternate segment theorem. 2 different theorems, 2 different results. Write the short theorem line, give the equality, then box your answer. Final sign-off. Repeat the quick win, DST, diameter, same segment, tangent, and the 10-second substitution check. Use that before every circle question in your next mock. For more worked examples and a downloadable practice sheet with full mark schemes, visit jcacademyonline.co.uk. Stay curious.